Okay, in this video we want to find the gradient and the directional derivative of the function f parentheses x comma y is equal to x squared times y cubed minus 4y at the point 2 comma negative 1 in the direction of vector v is equal to 2 comma 5. And if you notice in this problem we're given v, we're not given the unit vector. And so we will first try to get the unit vector. So the unit vector is equal to v divided by the magnitude of v. So v is 2 comma 5. The magnitude of v would be the square root 2 squared plus 5 squared. So 4 plus 25, so that would be square root of 29. So we can say the unit vector is equal to 2 divided by square root of 29, comma 5 divided by square root of 29. So that's the first thing we need to get. The next, we need to get the gradient. So the gradient is the partial derivative in terms of x and y. So when we take the derivative in terms of x, we would get 2x times y cubed and for x. This is because we're treating y as a constant. So it is as though y is like a random number 5. And if you have x squared times 5, 5 would remain the same. And that's why this is gone, because it's as though it's like 5, and when you take the derivative of 5 you would get 0. So now we do the same thing for y, and for y we would get 3x squared times y squared minus 4, and now we plug in our point 2 comma negative 1, and so when we plug in 2 comma negative 1 we would get negative 4 comma 8. So now we're close. So in order to get the directional derivative, we take the dot product of the gradient times the unit vector. So we have negative 4 comma 8 times the vector 2 divided by square root of 29 comma 5 divided by square root of 29. And when we do the dot product, we would get negative 8 divided by square root of 29 plus 8 times 5 is 40, 40 divided by square root of 29. And so our final answer for the directional derivative is 32 divided by the square root of 29. And that's all we need to do.